Hi everyone, thank you so much for joining us for this Postgraduate Masterclass series brought to you by Heriot-Watt University. I am delighted to be joined by Dr Theo Dounas, who is our Head of Discipline for Constructed in Virtual Environments programmes, and also Alya Rizvi, who is our programme lead for the MA in Interior Architecture and Design programme. And they will both be presenting today for this fabulous webinar on design science for the fourth industrial revolution, how designers can harness artificial intelligence and data to create a better future. So thank you again so much for joining us. You will notice that we have a chat function available throughout the webinar. So please do feel free to drop in any questions relating to the research topic or the programme structure as they come to you, because we will be answering these and all the other questions at the end of the session. So without further ado, let me hand over to Theo so we can find out a little bit more about the fourth industrial revolution and the part it plays in our industry.
Hello, nice to join this webinar. I'm going to be discussing essentially part of my research for automation and digital activities in design. I'll explain essentially what design for the fourth industrial revolution looks like, and then Alya will explain the MA in Interior Architecture and Design, and obviously we'll be here to answer any kind of questions you might have around the topics we're presenting today. So first of all, my expertise lies within automation in design and construction, and when we discuss automation, this might mean that in particular we're discussing digital automation, so essentially using computers and computing systems to automate part of design tasks or automate part of construction tasks. I was initially trained into shape grammars, so essentially kind of more classical, when I say initially trained, I mean my PhD is in shape grammars, which means essentially that we are trying to find ways that you can break down a composition into its constituent parts and then find the logic with which you're able to design, and then if you have that logic, you're then able to explain it to a machine essentially. I'm a little bit oversimplifying, but I think that gets you the kind of general idea. And in the past 7 years, I've worked tirelessly on to developing a new field within automation for design onto blockchain. We were looking into the technology essentially that runs cryptocurrencies. Beyond cryptocurrencies, that technology blockchain has a lot of implications for the architecture, engineering, and construction industry, essentially because it is a governance technology. So it's a technology that allows you to make better decisions throughout a project. So throughout this presentation, I will be discussing smart contracts. So essentially, this is software running on blockchain. We will touch a little bit on artificial intelligence and much more on the generative part, and then automation and digitization and what a designer could do essentially with these tools or with these technologies. But before we go into that, I'd like to talk a little bit more about the challenges that you might be facing as a designer in the next 5 to 6 years. So I think the first one would essentially be the kind of challenge that any kind of built environment professional is facing in terms of carbon impact. It doesn't matter if you're working in design or construction in the built environment, if you're working with buildings, if you're designing buildings, if you're constructing buildings, part of the deal is that we need as an industry and as an industrial ecosystem to reduce our carbon impact. And this means obviously that it doesn't only mean the operational carbon, right? So essentially heating and operating buildings or cooling buildings down, but also the embodied carbon. And from that point of view, that brings us into a very, very, very tight and difficult spot, because at the same time, we have globally increasing populations all around the world, and we have an increasing need for shelter, right? So we need more buildings, but also we need the current buildings that we have to operate at a much more optimized, much better kind of conditions. And this not only means operational carbon, but also potentially the way they function, right? So how do you take a building and retrofit it and changes interior so that you have a better functionality. If you try to only look at the engineering part of the equation, you will find out that a lot of times you can actually reduce its operational impact of a building just by making a smarter and much better interior architecture and design on that kind of idea. But carbon is not the only challenge that we're facing. We have had in the past 5 years the rise of generative artificial intelligence, and through that we're looking essentially for the potential, or at least big companies are looking for the potential to eliminate the need for labor in particular aspects of their process. But at the same time, we have the potential for issues of copyright and data ownership, more so in the way these generative artificial intelligence models have been trained. And the way they have been trained is that they have taken essentially a look at everything that has been published, whether this is text or images, and they have trained complex algorithms so that they statistically generate the closest one to the one you're desiring. And in many cases, these models have not essentially paid for the labor, the intellectual labor that a designer has done in creating those data assets. But if I also flip the coin, right, if you're operating as a designer at the moment, you will find that in many cases, a generative artificial intelligence might help you with certain processes, whether this is through using a large language model such as ChatGPT to fill in forms and cut down on your bureaucracy, or using a diffusion model for generating, for example, conceptual images, or actually creating renderings in a much faster, much more easy kind of way. So these challenges are not easy to solve exactly because they are putting us into a tight spot. They don't have an easy answer on whether you are, pro or against artificial intelligence, because you might be able essentially to harness in your job this kind of power. But before we go more into the solutions, I'd like to take a step back and discuss a little bit more on the design science part and what does that mean essentially on the research level. And if you're a designer or if you're working in any kind of design capacity, you will find out that design is a kind of discipline that has wicked problems, right? So you don't get one answer or one type of answer into a particular design problem. When you're training as a designer, you're training to be empathetic, you're training to work with people, and you're also training to understand issues from a complexity of points of views, a lot of times with a lot of issues that are in conflict between them in a design, right? So, and this is what we call a wicked problem, a problem that does not have a very easy answer, but requires, let's say, more of a development of a resolution. Design was not used to be scientific, let's say it was a lot of times made to be on the side of the arts, I would say. But in the last 20 years, we had the idea of the rise of the design science research, where essentially we are using design as a scientific activity. I have to say, architects and interior designers have been doing this for a very long time in terms of developing essentially an artifact. But the past 20 years, we have been able essentially to systematize this and move beyond the idea of design as practice. So what is design science research, right? So this is a way where we distinguish between how things are at the moment, and this is what science does. It does try to understand the world, understand how it works, understand all of the intricacies of how it performs, whereas design is trying to find out how things ought to be, right? So how should we improve things? And always design is an activity that is interventionist, right? So we go into the world and we change it so that it becomes better. Now, the idea here is that we try to design artifacts and processes, right? And this would be essentially also an environment or an object or a virtual object or a virtual environment. And then we try then to go back into the users and evaluate this and say, well, okay, we don't have a clear answer because it's a wicked problem. Do you think this would work? Again, I might be oversimplifying a little bit because we have also other indicators that we might evaluate a design with to understand whether it works or not. But essentially, we gather data from the environment. We try to understand essentially the organization, the technical kind of requirements, and obviously the problems and opportunities that come with particular problems. And through that, we kind of test this against the kind of design outcome that we're trying to develop. And on the other hand, also a designer also has knowledge, right? And we have expertise and experience. And we also have what we might call meta artifacts, right? So design products and design processes that work beyond the level of simple knowledge. And from that point of view, you also try to take the design artifact, the product, the environment, and test it against the knowledge that you have as a designer, right? So, and these kind of cycles essentially kind of comprise what we call design science research. So we try to essentially develop designs in a kind of more systematic and rigorous kind of way so that we are able to respond to the challenges I mentioned earlier, essentially. Now I'm going to move on to show some examples, right? So one of the things that you might be able to do as a designer, whether you're working at the level of architecture or interior architecture or at the level of a product designer, we had essentially in the past worked with a research and innovation project with a Scottish company called Rashwood Ltd. Rashwood develops essentially timber products for the built environment. And they came to us through the Construction Scholar Innovation Center, now called BEST, to develop a timber panel essentially for interior and exterior applications. So they wanted essentially to take timber paneling that they were developing only in the form of boards on a very simple basis and industrialize the process. So they came to us and said, well, can you just create an industrial product for us out of our raw material? And we said that we can also make it fully demountable. So you can actually disassemble it very easily, but also make it as zero carbon possible as we could, right? So we kind of introduced, from our point of view, the idea that we will not use any kind of metal or plastic fixings into the product. Everything will be timber, and by definition, timber is one of the most sustainable materials because you can. It's a carbon sequestration material, right? So it captures essentially CO2 in the form of trees, but also you can recycle it much more easy than say metal or timber because it's biodegradable, right? So what better could you do? And from that perspective, we developed essentially a very complex geometry where you could assemble the panel, you could develop it essentially in an industrial manner through a clever use of geometry and the tools that Rashwood already had. But also we went into the process of testing that geometry in terms of performance, right? And you can imagine the way the joints behind the panel work in a kind of clip-on, clip-off kind of fashion. And you probably have used products like that in your everyday life all the time. And this was a combination of, first of all, design in terms of designing the geometry. And we not only developed this in a virtual model that you see here, but we also went into giving our design geometry to engineers so that they could actually test it before we would actually build it. And we went there through a rigorous cycle of designing the virtual product, then testing it in reality also with tradespeople, so that we see it would work on a site, and then going back into understanding how we would improve it essentially. From this, I will also take you now to my work with blockchain and decentralized ledger technologies. So from developing a product that is about to enter the market into a kind of fully digital kind of idea for the fourth industrial revolution. And from that aspect, I'll try to explain what the blockchain is. Right? So a blockchain is a network of computers where they all hold the same kind of information, the same ledger, essentially. And there is no kind of central authority that coordinates the whole network. They use a very clever algorithm to coordinate between them. So every piece of the network holds the truth, and they coordinate between them in terms of what the next transaction is going to be on the ledger. So in a very simple kind of, let's say, cryptocurrency kind of approach, the blockchain Bitcoin, for example, is only recording plus and minuses. But if you can record plus and minuses, you can also do multiplications and division. And if you can do that, you're essentially running as a small computer. So what we can do on this global network is we can actually run software. And from that point of view, we can start assigning part of what we're doing as designers into that network and give it some part of the responsibility for what we're doing. So one of the prototypes we developed back in 2018 on blockchain and decentralized technologies is on the framework for decentralized architectural design. If you can go to the next slide, please, Lindsay. Where we developed a software product that would allow you to take a wicked problem from the point of view of the problem owner, publish it on a blockchain, and then invite designers to solve it for you. And then the blockchain essentially would actually take into account the two states, right? So we could actually have the designers work in a completely competitive fashion, or we could, and then this is the slide that you see here, right? So if designer 2 would solve it, then they would get paid automatically, right? Blockchain is fantastic for automatic payments. And if designer 3 would solve it, then they would individually get paid. However, there is also a collaborative function that we built into the prototype, which is the next slide. And there we would also use the blockchain to synchronize the nodes and the design definition from one designer to another. And the system would note the kind of contribution that its designer would take into solving, within quotation marks, the problem. And through that kind of idea, we would be able then to automatically pay everybody who would contribute to creating the design artifact, creating the design solution for our problem, right? So for the first time, we kind of demonstrated that we could actually publish a design problem, but then also coordinate its solution without having to know the designers that are involved, right? So everything happened essentially through the internet, completely anonymously, and you could actually also take care of incentives or payments and so on and so forth for this kind of idea. That was a really simple one, and we kind of then developed another prototype with my good friend Basim Jabi from the University of Cardiff, where we developed essentially a combination of building information modeling with blockchain, where we could trace essentially product assets within the model. So one of the problems that we have essentially in built environment, going back to the idea about embodied carbon, is that most buildings at this moment are produced in a very linear kind of fashion, right? So we create a new building, and a lot of times this building is created with only one function and with no kind of potential for adaptability, or even tracking essentially where its materials come from or where they go to, right? So right now, if you are trying to develop any kind of circular economy that will reduce the embodied carbon, you have no software that would help you essentially keep track of what is contained within a building. Hence, by combining the building information modeling, right? So how you model a building with the traceability function that you have through tokens on a blockchain, you would be able essentially to save all of your files for perpetuity, right? For 30 or 40 years. And then you could actually keep track, for example, where a window or a piece of wall or a column actually is within a building with all of its characteristics. So we would create essentially a product passport that would live on the blockchain, and it would essentially take all of the benefits of a blockchain, data availability for perpetuity, but also transparency in terms of transactions. So this is kind of fundamental in terms of enabling a circular economy for interiors and interior architecture, where you could, for example, when you start designing a project, have already an array of products at your availability where you could actually reuse products or materials that are about to be demolished or demounted from another project. And it helps essentially coordinate projects between them, right? Projects that are at the end of life with projects that now are on the design phase, and give essentially to the designer massive more opportunities on that kind of idea. And the fundamental here is the idea of token, right? So you can have fungible tokens that are exchangeable in the same way that you get essentially a game token that you can use in an arcade, or non-fungible tokens, so essentially digital products that are unique and are not interchangeable to the level of the blockchain, essentially. So these are some good examples on what we have done in research. We're using fourth industrial revolution technologies in the realm of design. They have, I would say, wide-ranging impact from that point of view. And I would kind of take this as an opportunity to summarize on what could an entrepreneurial design response could be to the fourth industrial revolution. And I would say it's, first of all, to create zero carbon products for interior architecture and buildings retrofit, right? So I think there are opportunities within projects where a designer not only can act as the kind of chief orchestrator of an interior or of an architecture project, but also find ideas where they can offer to the market in a much more innovative and zero carbon manner. But also, I think everybody who is a designer and are creating design data in a way of models, sketches, any kind of structured kind of information that you create as a designer, you could actually start thinking of how you could contribute to larger and wider directives in terms of design data on training AI, but with the idea also that you could get something back. So only participating projects where the project is not extractive, right? So they're not actually only taking your data without actually giving anything back. These projects do exist out there. And if you'd like to know more, you can also contact me. My email is public on the website. And as a last point, to basically say that you can integrate the interior architecture design process with the data cycle, right? So really look at how you harness the data that you use as a professional during the design process, so that you are able to gain a market advantage from that perspective. And this is where the use of AI can really help in terms of automating part of, let's say, the boring stuff that you do as a designer, and only then clear out your time to focus on what is more important, which is actually the combinatorial aspects of what you do, the creative aspects of what you do, and leave the kind of boring stuff to the AI. Even though I have to say that the newer diffusion models also could be a source of inspiration, at least in certain aspects of the design cycle. But I think it's also very, very, very early on. And I'll leave you with this nice cover of a book. This is not mine, actually, right? This was designed by the collective called Space Caviar. It was presented at the Venice Architecture Biennale, I think 4 years ago. It's all a haze a little bit with the pandemic, or I've lost count of years with those kind of situations. But essentially, the book explains how you could design without depletion, right? So how do you design without reducing the creation of spaces and architecture into an extractive discipline, but actually designing without depleting our physical environment. And with that, I will pass on the baton to our program director for the MA in our interior architecture design, Alya Rizvi, and she will explain what we do in that program.
Thanks, Theo. Thanks so much. Okay, so hi everybody. So my name is Alya and I'm an architect and academic. I'm going to run you through the program structure now. So the idea is, hopefully you can see on the slides that for the first semester, starting from September, running into December, there are 3 modules or courses that you would take. The first is Tectonics, Tools and Technology. And the idea behind that is that this is a project which is a design studio project, so it focuses on design and 3D modeling. So you'll be working here with a range of software and other facilities to do with 3D modeling, laser printers, 3D printing facilities, in order to realise, hopefully, a really good project. This year, we worked with a live client, Network Rail, and to design an installation at Edinburgh Waverley Station. It was to do with students were looking at innovative solutions to engaging the travelling public. The next module really focuses on sustainable design and management. This one gives you the opportunity to work across disciplines. So we have students from fashion, design management, interior architecture coming together, collaborating on a project which relates to the SDGs, the Sustainable Development Goals. It looks at how they impact design, how they impact designers. And then we have a module or a course in design thinking and innovation. Here it's really about expanding your creativity and problem solving skills. So you can see a lot going on in the first semester. In the second semester, we have another 3 modules. We have another design studio course, which is communities, engagement and practices. It's working with a community organisation. Students will come together again on looking at a problem or an issue, just kind of looking at a problem or an issue that they can help solve through design for a charity. This year, again, we worked with a organisation which helps and supports artists and makers in Scotland with developing finding them rentable spaces where they can actually come and work. So it's mainly for independent artists and makers. But students came up with some fantastic solutions. They had the opportunity to work with a live client on a live project where they came up with ideas and solutions and then presented those to the client. A very exciting project. I actually do have some images at the end to show you. We've also had research methodologies. Research methodologies is really looking at why research is important to design. Yeah, and then you have an opportunity to actually then carry out some research. And particularly throughout the project, actually throughout all the courses, but perhaps more so and in your final project. And then there is an elective, which is actually, well, the one which is called Design Technologies and Business Enterprise in green is in green because it's actually an elective, so it's a choice. So you have the choice to take Design Technologies or Business Enterprise. And then finally, in the third semester, you have a final project. A final project basically allows you to develop an interest that you have, and we as tutors will support you right the way through that project. Okay, you'll be supervised through that project with a team of experts in the interior design and architecture department. Okay, so you have basically a total of, you might be wondering what those numbers are next to each one of those descriptions, those courses. What you find is that each course has a credit weighting, so that you can see that the design courses have 30 credit weightings, and then you've got 15 for the others, and then of course 60, a lot of weighting on the final project. So a total of 100 to 180 credits to get your master's qualification. You have 2 entry points. You can join the course in September, but also you can also join the course in January. Okay. And I think that, yeah, and then the other two, these slides are really examples of final project, major project work. They're taken from a student's journal. They're looking at just various different ways of how students have been innovative about how they've gone about designing their projects, being really innovative and excited about the way they're introducing some really nice ideas in their projects. You can see the CAD level of CAD skills and drawing skills. Okay, and we will support you right the way through those. Again, the idea of looking at different materials, looking at construction details, looking at developing furniture ideas for specific projects. Okay, so really just to give you an idea of the level and quality of work that you'll hopefully be engaging with if you were coming to Heriot-Watt.
Thank you so much, Alya and Theo. That was wonderfully insightful. So I do hope everyone's really taken something away from that. I've not actually had any questions come through. I feel like we probably covered off a lot in that kind of like segment, so that was perfect. So I would just say if anyone does have anything specific to research questions, perhaps program structure questions, do send across to either Theo or Alya directly, or you can get in touch with the team at Study With Us at hw.ac.uk, and they can of course get back in touch with you regarding anything to do with our programs. But yeah, just a massive thank you again to Theo and Alya. We will also have this webinar up online so that you can refer back to it should you have any sort of questions about the programme or want to kind of delve back into the topic. So thank you so much for attending, and hopefully we'll see you in the future. Thank you.